Swayam Prabha. Digital India. Educated India.
Welcome to the paper on Organic Chemistry 3 in the Unit 1 Nitrogen containing functional group. In lecture 6 we are going to study about amino compounds part 4. I am Dr. Balaji, currently working as Associate Professor in the School of Biotechnology at Jawaharlal Nehru University. This project is sponsored by DTH Swayam Prabha, MHRD, New Delhi. The topics that will be covered in this session include mainly reactions of amine. We will start our studies with the reactions of amines with alkyl halides, carbonyl compounds, acyl derivatives and nitrous acid. In the acyl derivative, we will be looking at acid reactions of amines with acids, acid chlorides and acid anhydrides. Then we will study about what is Edmond degradation. Then we will move on to study about carbalamine reaction, Manich reaction and Halfman mustard oil reaction. We will also be studying about Halfman exhaustive methylation and Halfman elimination reactions. Finally, we will study about the various oxidation reactions of amines. Then we will study about the test to differentiate primary, secondary and tertiary amines. We will study mainly about Hinsberg test and nitrous acid reactions. Welcome to the next session. In this session, we will be looking at reactions of amine. So, when we look at the reactions of amine, the first one we are going to look at is reactions with electrophiles. When we look at the amino compounds, the nitrogen is having a lone pair. So, when the nitrogen is having a lone pair, this can behave like a very good nucleophile. So, that means the reactions will happen with electrophiles. And we also have a site where the hydrogen can be replaced. So, this leads to site for substitution or elimination in the amino derivatives. So, there are two major places where the amino compounds can undergo reaction, one on the nitrogen, another one with the replacement of hydrogen. So, the first one when we talk about the reactions with electrophiles, the first one is the alkylation reaction. So, this is nothing but a SN2 reaction. So, alkyl halide when reacted with an amine leads to substitution of the amino group. And then we have next type of reactions, carbonyl addition reaction. So, carbonyl groups when reacted with amino compound gives, depending on the primary, secondary amino compounds, we get imine or enamines. And then acids or acid halides or anhydrides reacts with the amino compound to give the acylated product. We also have the reaction with the nitrous acid which leads to the formation of diazo derivatives. So, these are all the major reactions where electrophiles are involved. We also have Halfman elimination reaction and oxidation reaction. So, these are all the various reactions we will be looking at in this session. So, let us start with the reactions with acid derivatives. The primary amines and the secondary amines basically react with either acids or acid halides or anhydrides to give amide. So, if we look at the reaction, here we have a amino compound. The amino compound is a basic unit. The amino functionality is basically a basic unit, and this basic unit reacts with an acidic unit. That means the acid halide or acids directly or acid halide which are basically acidic units or anhydrides which are neutral. So, when these two reacts with the amino compounds, we end up with a neutral derivative. So, the neutral amide is formed. So, the amide group is the neutral one here. So, here the group Y actually is being replaced. That means it can be a hydroxy unit. If it is a hydroxy unit, that is carboxylic acid. If it is a halogen, that is an acid halide. If it is OCO or acyloxy group, then it is basically a anhydride. And the unit RCO is actually incorporated into the final product as a amide product. So, the amine, one of the hydrogen is being replaced with an acyl unit. So, when we use excess of acylating agent at high temperatures, the primary amines undergo diacylation. That means we have in the primary amines two hydrogens are there. So, these two hydrogens can be replaced by two acyl units. So, that is the reason if primary amine is used as a starting material, instead of the monoacyl derivative, we may also get the diacyl derivative if the temperatures are high and if we are using large excess of the acylating agent. But in the case of secondary amine, there is only one hydrogen, so we get only the monoacyl derivative as the only product. So if we have to look at the diacyl derivative, then we have the RCO unit with the nitrogen. So there is also another R unit, acyl unit, and we have the R group. So as secondary amine, primary amine, when treated with the excess of acyl unit, so two acyl units can be added to the amino derivative. So we have a diacyl derivative as shown here. When we look at the reactivity of the acids, acid halides and anhydrides, the acid halides reacts very fast, followed by anhydrides, then acids react very slow. So this amide bond formation reaction, when we talk about, that is the acylation reaction. So here acid halides react very well with or very fast with amino derivatives, followed by anhydride, and finally acids react much slower. Why we have to look at the amide bond? If you look at the amide bond's significance, basically various peptides, proteins and biomolecules, drug candidates, all of these have the amide unit as the backbone. So the amide bond, whatever we are talking about, that is the CONH2 bond. So this CONH2 bond is basically either it can be NH or NH2, or even it can be a di substituted one. Here we can have both R groups also may be present here. So these kind of amide unit, amide functionality is the main backbone in various drug molecules, biomolecules and other things. For example, here if you look at some of the important drugs, Lipitor is an important drug used for a cardiovascular disease. So this has a amide unit, amide bond as shown here. And we also have lidocaine, which is a local anesthetic that is being used. This also has a amide bond. And amoxicillin, an antibiotic used, has two types of amide bonds. One is a open chain one, another one is a cyclic one. So here we have a cyclic amide and a open chain amide. So in all these cases, if you look at, amide bond is present in all these kind of drugs. So in fact, if you look at the pharmaceutical industry, the most important and the common reaction for the drug formation is basically the amide bond formation. In other words, what we can say is 25% of all the drugs contain at least one amide bond. So that is the reason amide bonds are very important in synthetic chemistry. Next, let us look at the reactions with halogens. Amino compounds react with halogens with replacement reaction. That's what we have seen here. So when halogen reacts with amine, what happens is one of the hydrogen is actually being replaced here. So that is what is the reaction actually happening, and we end up with the HX as the byproduct in this reaction. HX is nothing but a acidic unit. So when the acidic unit is formed as a byproduct, we use a base to remove this byproduct whatever is formed in this reaction. So that is the reason this reaction is carried out under basic conditions. So the primary amine has two hydrogens, so both the hydrogens can be replaced by the halogen unit as shown here. We have one mono substituted, that is one of the hydrogen is replaced by the halogen atom. So this is a mono halogenated amino derivative. Here we have the dihalogenated amino derivative. So in the case of primary amine, we get both the mono halogenated and the dihalogenated derivatives. When we use secondary amine contains only one hydrogen, so that one hydrogen is replaced by the halogen atom. So we get the mono halogen substituted product. So this is very similar to the acylation reaction. So in the acylation reaction also we had seen, if you use a primary amine, we end up with a monoacyl derivative or a diacyl derivative. And if you use a secondary amine, we end up with a monoacyl derivative. Similar to that, halogen reaction also is very similar. The next one is reaction with the nitrosyl chloride. So, amino compound, especially the primary amine, when reacted with the nitrosyl chloride, leads to the halogen derivative, that is alkyl halides are formed as the major product with the concomitant loss of the nitrogen gas. So, this reaction is very facile because nitrogen is formed as the byproduct which escapes from the reaction medium. So, the reaction proceeds very effectively. And if we treat a secondary amine with as nitrosyl chloride, we end up with the N-nitroso derivative. So, that is nothing but the N-nitroso amine is formed as the main product. So, these are all the two types of reactions. The primary amine gives the alkyl halide, whereas the secondary amine gives N-nitroso derivative when reacted with nitrosyl chloride. So, the next one is the reaction with the Grignard reagents. Primary amine reacts with the Grignard reagent to give alkanes. So, this is the product which is formed, and one of the hydrogen is replaced by the Grignard reagent. So, depending on the temperature, we may get different type of products. So, that means the replacement of either one hydrogen or two hydrogen takes place, leading to the hydrogen being replaced by the Grignard unit, that is the MgX is replacing the hydrogen atoms. And if we use a secondary amine, then we end up with a mono substitution. So, these are all the different types of reactions where hydrogen atom is being replaced in the case of amino compounds. The next reaction is reaction with the phenyl isocyanate. So, here again the primary or the secondary amine reacts with the phenyl isocyanate to give the substituted urea derivative. These are basically crystalline compounds. They can be used as confirmatory test for the amino compounds. So, in olden days people were also using these kind of reactions to characterize the amines, because amines are basically solids or liquids. So, in those kind of cases, to characterize a particular amine, the amine derivative was converted to the urea derivative, and that urea is a crystalline compound in most of the cases, which can be characterized very easily. As I mentioned, before the advent of spectroscopic techniques, in olden days this was the major reaction to characterize amino compounds. If we use primary amine, we get N-monoalkyl urea derivative, and if you use a secondary amine, we get N-dialkyl urea derivative. So, these are all the ways by which amino compounds can be converted to the urea derivatives. Instead of isocyanate, if we use isothiocyanate, that means as shown here, instead of NCO, if the oxygen is replaced by the sulfur, we end up with the phenyl isothiocyanate. When the phenyl isothiocyanate reacts with the primary amine or a secondary amine, we get the corresponding thiourea derivative, which is very similar to the urea derivative. So, this reaction is also another reaction where the hydrogen atom, that is one of the hydrogen atom from the amino group, is replaced by another unit. So, this reaction is a very crucial reaction. That means for the characterization of peptides, this reaction is generally used. So, the N-terminal unit is actually converted to identify the sequencing of peptides. So, this reaction is called the Edmond degradation reaction. So, in this Edmond degradation reaction, peptides are converted to the corresponding phenyl thiohydantoin amino acid derivatives. So, what are the reaction takes place is basically the N-terminal amino group is reacted with the phenyl isothiocyanate. So, this leads to the phenyl thiocarbamyl derivative, and this phenyl thiocarbamyl derivative on heating in the presence of an acid leads to the cyclized product. So, that product is called phenyl thiohydantoin amino acid. So, here is the amino acid what we are talking about. So, this R group is very essential. Depending on the R group, we say what is the corresponding amino acid. So, that is the same R group what is present here. So, the N-terminal amino acid is the one which is actually converted to the corresponding amino phenyl thiohydantoin derivative, and once this happens, this particular bond is broken and we actually end up with the corresponding amino acid whatever is formed. So, like that we can actually sequence the entire peptide by one amino acid group after another amino acid like that. So, this is a very important reaction, and it is also called as the Edmond degradation reaction. The next one is the carbalamine reaction. So, here the primary amines react with the chloroform in the presence of a alkali base to give a very smelling or a foul smelling compound called isocyanide. So, this reaction, the isocyanide, are also called as carbalamines. So, this reaction is basically the chemical test to generally find out the presence of primary amines. So, in the laboratory we carry out this reaction quite often, and in this particular reaction dichlorocarbene is the intermediate that is next is a carbalamine reaction. So, in this reaction a primary amine is reacted with the chloroform in the presence of a alkali base, preferably, or in most of the cases it is sodium hydroxide is used as the base, which leads to the formation of a bad smelling compound, that is a foul smelling compound called isocyanide, and this compound is also called as carbalamine. So, that is the reason this reaction is called the carbalamine reaction, and this reaction is basically the chemical test which is used in the laboratory to find the presence of primary amines. So, if a chemical substance is given to you and if you are asked to find out what is the functional group present in that particular compound, if it is a primary amine, we generally carry out the carbalamine test to confirm that whether we have a primary amine or not. In this particular reaction, dichlorocarbene is the intermediate that is involved. Basically, this dichlorocarbene is formed from the alkali base and chloroform. So, this leads to the formation of a CCl2 species, which is called the dichlorocarbene, and this dichlorocarbene converts the primary amine to isocyanide, and this reaction is also called as Halfman isocyanide synthesis. So, in the previous sessions we have seen about preparation of isocyanates. So, in that we have seen this as one of the important process for synthesis for the preparation of isocyanates. So, the overall reaction is given here. A primary amine reacts with the chloroform in the presence of a sodium hydroxide, that is alkali base, forms a compound called carbalamine or the isocyanide. So, the NC bond is shown here. This is the isocyanide unit, and sodium chloride and water are formed as a byproduct in this reaction. Let us look at the mechanism for this reaction. So, as I mentioned, in this particular reaction, a chloroform reacts with a strong base, that is a alkali hydroxide anion, with the loss of chloride ion to give CCl2, that is a dichlorocarbene is formed as the intermediate, and this intermediate now reacts with, because this is having electron deficient carbon, because this particular carbon has only 6 electrons, and we have a nitrogen which is having a lone pair of electron. So, this is electron rich, this is electron poor. So, what will happen? The electron rich substance reacts with the electron poor species. So, that means the amino lone pair on the amino nitrogen is being given to the carbene, that is dichlorocarbene. So, this leads to the intermediate as shown here, and this intermediate loses a proton. Basically, what happens is one of the hydrogen from the amino, that is the NH2 unit, is shifted from the nitrogen to carbon. So, that is how we see one of the hydrogen being shifted from nitrogen to carbon. So, here is a hydrogen attached to the carbon. This nitrogen now, instead of having 2 hydrogen, it is having only 1 hydrogen. So, this leads to the concomitant loss of the hydrogen unit, that is a base abstract this particular proton. So, that is the base is the hydroxide unit. So, this hydroxide unit abstracts this particular proton, and the chloride is the concomitant leaving group, which leads to the formation of this amine type intermediate. And this amine type intermediate, there is another hydrogen atom which can be abstracted by the strong base. So, this hydrogen is also lost, and with the concomitant loss of the chlorine also. So, we end up with a compound called the NC unit. So, nothing but what we have here is the isocyanide unit. So, this is the overall reaction for the formation or the conversion of the amino compounds to the corresponding isocyanide. So, this is the reaction mechanism for the carbalamine. So, the next one is the Mannich reaction. So, here we are talking about the amino alkylation reaction. So, we have seen that carbonyl groups can react with the amino compounds. So, this is the one here in this particular case. Mannich reaction is an example of amino alkylation reaction. So, here the reaction happens between a carbonyl compound. Here the carbonyl compound should have at least one acidic proton. So, this is the carbonyl compound we are talking about, which is having at least one acidic proton, and we have an intermediate. There are other substrates which are involved in the reaction is a formaldehyde and a primary amine, or even in some cases we can also use a secondary amine, or ammonia also can be used. So, that means we can use the amino derivative can be either ammonia or primary amine, or it can also be a secondary amine. So, all the three amino derivatives can be used in this particular Mannich reaction. So, this condensation leads to the formation of beta amino carbonyl compound. So, this is also called as Mannich base. So, we have the amino unit, we have the carbonyl unit. So, these two are actually present, and the formaldehyde is added here as one of the carbon unit, extra unit. So, this final compound, if you look at there is a amino group in the beta position. So, if we start this is the alpha, this is the beta carbon. So, in the beta carbon we have a amino group which is with respect to the carbonyl unit. So, we call this as a beta amino carbonyl compound. Let us look at the mechanism for this particular reaction. So, this first reaction actually forms an amine as an intermediate, important intermediate. So, this reaction itself can also be looked at the formation of amine from amino compounds. So, when an amino compound, especially here what we are talking about is a primary amine. So, when a primary amine reacts with the carbonyl compound, here we are taking the example of formaldehyde as the carbonyl compound. So, this carbonyl compound and the amine both reacts to give the amine as the intermediate. So, this is one of the reactions of amino compounds with carbonyl compounds. So, what is the first step? The carbonyl compound has a nucleophilic oxygen. So, this abstracts a proton from the acidic conditions. Reaction conditions are basically acidic in this particular reaction. So, one of the proton is being abstracted by the carbonyl oxygen. So, this leads to this particular intermediate. Oxygen being electronegative pulls the carbonyl oxygen double bond electron towards itself, and we end up with this particular intermediate. Now, we have a electrophilic carbon. So, this electrophilic carbon is being attacked by the nucleophilic amino nitrogen. So, nitrogen is having the lone pair. So, this lone pair is the one which attacks this electrophilic carbon atom, and we have this particular bond. The carbon nitrogen bond is formed in this particular case, and this loses a hydrogen atom as a proton. So, that means the bonded pair are being taken by the nitrogen. So, the nitrogen regains its lone pair of electrons. Now, this lone pair comes between carbon and nitrogen to form the double bond with the concomitant loss of water molecule, because we have a hydroxy unit here and a proton is lost. So, this proton actually is being captured by the oxygen unit. So, because oxygen is having the two lone pair of electrons. So, once it abstracts this particular hydrogen atom, it becomes H2O plus ion, which is a very good leaving group compared to a OH group. So, that is the reason this water is the water molecule is lost very readily, which leads to the formation of the amine intermediate. So, here nitrogen is having the positive charge. So, this is one of the important intermediate that is formed when an aldehyde reacts with the primary amines. So, once this amine is formed, this amine again reacts with the second carbonyl compound. So here we have talked about a carbonyl compound containing one of the acidic hydrogen atom. So that means the carbonyl compound should contain one alpha hydrogen atom which is acidic in nature. Because of the presence of carbonyl group, this hydrogen is much more acidic, and in the presence of a strong acid, the reaction is actually carried out in the presence of a strong acid. So similar to the normal carbonyl addition what we have seen here, the proton adds to the carbonyl oxygen, and the steps, if you look at the number of steps how the reaction actually proceeds are more or less similar up to here, the formation of the carbocation. So here this is the unit where the corresponding carbon becomes more electrophilic in nature. In this particular case, this hydrogen is actually acidic in nature. So because the alpha hydrogen atom which is acidic in nature, this is lost very readily, and we end up with a ene derivative. So this E and O all, that means we have the enol derivative. So what actually happens is we start with the keto group. Keto group in the presence of an acidic reagent getting converted to enol. So in this particular reaction, keto enol tautomerism is the first step which actually happening in the second part of the reaction. So the first part of the reaction, we have the amine as one of the final product, and in the second part of the reaction what happens, because we have two substrates, one is a formaldehyde, another one is the carbonyl compound containing alpha hydrogen. So these are all the two substrates. So one substrate leads to the formation of amine, the second substrate now leads to the formation of enol. Now we have two intermediate in this reaction, one is an amine, another one is a enol. So the reaction now happens between the enol and the amine. So in this particular case, nitrogen is actually electronegative in nature. Since in the amine the nitrogen is having a positive charge, it pulls the bonded electron towards itself, and which makes this particular carbon electrophilic in nature. So there is a delta plus charge develops on this carbon, and we have a electron rich pi bond here. So this pi bond now attacks this electrophilic carbon, so that particular bond is actually formed. So this is the bond we were talking about, came from the formaldehyde unit, HCHO unit. When we talk about this particular carbon is the one which is present here in the center, which is having two hydrogens. So we have the two hydrogens here. So this is the formaldehyde component, and this is the amino compound, and this is the carbonyl component. So here if you look at the starting keto derivative, we have two hydrogens which are present here, and we lost one hydrogen and we only have one hydrogen here. So that is how the alpha hydrogen is being lost here. And in this case what happens is the double bond, the oxygen's lone pair is coming towards the oxygen carbon bond. So we have a double bond between carbon and oxygen. Because of the loss of lone pair of electron, the oxygen becomes positive, and this is the intermediate which is formed, and this intermediate now loses a proton to give the corresponding beta amino carbonyl derivative. So this is the Manich base, whatever we call that, is formed in this particular reaction. So if you look at the overall reaction, the first one of the substrate, that is the formaldehyde, reacts with the primary amine to give the amino compound. So this is intermediate one, and the keto group gets converted to enol as an intermediate, and the enol reacts with the amine to finally give our final product, which is a beta amino carbonyl derivative, which is nothing but the Manich base. So the next one is the Halfman mustard oil reaction. So in this reaction, primary amines reacts with carbon disulfide, that leads to the formation of dithiocarbamic acid, and this dithiocarbamic acid reacts with the mercury chloride to give decomposition, and it also gives the alkyl isothiocyanate as the final product. So this is the mustard oil reaction, we call that. So the carbon disulfide reacts with the amino unit, and one of the hydrogen is being replaced and the CS2 group is actually added here. So, one of the sulfur gets the hydrogen atom which is being lost from the amino unit. So, one of the hydrogen moves from here to here, and that is how we get that particular intermediate. This is nothing but the dithiocarbamic acid, and this when treated with the mercury chloride gives our final product, which is the mustard oil reaction. So, this is having a very bad smelling compound, and this compound is nothing but a alkyl isothiocyanate. The next one is the reactions with the nitrous acid. So, we have seen the reactions of diacetization. So, in this particular case, when an amine reacts with the nitrous acid, gives a intermediate called diazonium salt. Here I have not given the diazonium salt. So, what we end up is Rn2 plus and X minus is the intermediate that will be formed. It is highly unstable, because especially in the case of alkyl substituted diazonium salts, they are highly unstable. So, in the reaction medium we have water. So, that is the reason the nitrogen is lost as the nitrogen gas, and we end up basically with a carbocation. A carbocation is formed, and this carbocation now reacts with the nucleophile OH minus to give the corresponding alcohol. So, that is the overall reaction in this particular case, and this is also a test for primary amines. So, the liberation of nitrogen is very crucial. We can actually see bubbles coming out of the reaction medium. So, this is a test for primary amines. And the next one is the von Braun method. So, in this particular reaction, a primary amine is reacted with benzoylation using benzoyl chloride. So, benzoyl chloride actually replaces one of the hydrogen to form the benzoylated derivative. So, this is very similar to the acylation reaction which we have seen. So, one hydrogen is being replaced. So, we end up with the amide compound, and this amide compound when treated with PCl5 gives the cyano derivative POCl3, and our final product obtained is corresponding halo derivative. If we use a PCl5, we end up with a chloro derivative. If we use PBr3, we end up with a bromo derivative. So, the corresponding halo derivative will be formed, and this halo derivative and treatment with the sodium hydroxide undergoes SN2 reaction to give the corresponding alcohol derivatives. So, this is how a primary amine can be converted to the corresponding primary alcohol. If we stop the reaction at this stage, we will end up with the corresponding halo derivative only, and the halo derivative can be further converted to the alcohol by treatment with the base. The next one is the deamination reaction. Deamination means removal of this amino group. So, that is what is the deamination reaction. So, here what we generally do is the primary amine is treated with the acid chloride. So, when an acid chloride reacts here, we end up with the corresponding amido derivative. So, this is the amide unit. So, once the amido derivative is formed, this is treated with N2O4 in the presence of sodium acetate. That leads to the N-nitroso compound. So, the N-nitroso amide is formed. So, this is an amide. So, this on heating gives the corresponding esters. So, the nitroso group is replaced by the oxygen unit, and this on hydrolysis with because this is an ester, hydrolysis of an ester actually gives the corresponding alcohol. So, in this particular case, the amino group, the NH2 group is being replaced by the hydroxy group, that is OH group. So, if we look at the overall reaction, an amino group is converted to an alcohol unit. The previous reaction also what we saw is an example of similar to this one only. So, in the von Braun method also deamination takes place. So, the amino group is being replaced by the corresponding hydroxy unit, and Reaction with N2O4 also is another example of converting a primary amino compound to intermediate. In the previous case, we have used benzoyl derivative. So, the benzoyl amide is actually formed when treated with the primary amines. So, here we can take any of the acid chloride, we end up with the corresponding acyl derivative, that is the amide, and the treatment of this amide with N2O4 is a crucial one, which forms the N-nitroso derivative. In the 1-bron method, we end up with the corresponding halo derivative by treatment with PCl5. So, this is the crucial step which is different between 1-bron method and the deamination method. So, once we end up with the N-nitroso derivative, that can be converted to the corresponding ester, which on hydrolysis gives the corresponding alcohol. The next one is the oxidation reaction. So, depending on what is the substitutions on this particular carbon atom, we get different products when an amino compound is oxidized using KMnO4. When the alpha carbon is monosubstituted, we get aldehyde as the final product after hydrolysis. So, this is nothing but the amine derivative. So, the amine is converted to the corresponding carbonyl derivative on hydrolysis. If we have
the alpha carbon is
that is one substitution,
we get ketone
on this particular carbon atom, that also gives us substituted amino derivative. So, here basically we end up with the aldehyde compound. Here we have a keto compound. So, basically the amine is hydrolyzed to the corresponding carbonyl compound.
If we have
hydrogen, then we end up with the aldehyde compound. If the substituent is an alkyl group, we end up with a ketone derivative. So, these are all the ways by which a carbonyl compound can be prepared from a amino compounds.
If the alpha carbon is tri-substituted, then we get
nitro derivative. So, depending on what is the substitution on this particular carbon, we can get either aldehyde, ketone or the nitro derivative. This is the oxidation by KMnO4. Depending on the different types of oxidizing agent used, we may end up with a different type of products for secondary amines. The previous one what we saw was a primary amine. Here when we have a secondary amine oxidation with KMnO4 gives hydrazine derivative. That means substituted hydrazines are formed. If we use sulfuric acid as the oxidizing agent, we end up with the dialkyl hydroxylamine derivative. So, these are all the different products obtained from the secondary amines. If you use another type of oxidizing agent, which is a peroxy acid, we get a different type of products. So, here some examples are given using Carose acid, that is peroxy monosulfuric acid. So, the primary amine when treated with the Carose acid gives various products. So, it produces N-alkyl hydroxylamine derivatives. It also gives aldoximes. It also gives hydroxamic acid. So, there are various places where the hydroxy group is introduced. One is on the nitrogen, because here on this nitrogen a hydroxy unit is introduced, and also on the adjacent carbon one of the hydrogen is being replaced by a hydroxy unit. So, these are all the various places where oxidation leads to different products, and this aldoxime is obtained from the corresponding starting material only, that is the amino compound only. And if we have substitutions on this particular carbon atom, this is again a primary amine. So, if you look at both the cases, we are using only the same primary amine, but there is a substitution on the
alpha carbon atom. If the alpha carbon is disubstituted,
we actually get a ketoxime. So, in this particular case, two alkyl groups are present. So, that leads to the formation of a ketoxime. If there is a hydrogen, that is called as a aldoxime.
And when the alpha carbon is tri-substituted,
starting material with the primary amine, we end up with a C-nitroso derivative. So, that is the major. So, in this particular case, there are no hydrogen that can be replaced on this particular carbon atom. So, in this particular case, only the hydroxy group is getting introduced to the nitrogen atom, and when there are three alkyl units attached to the adjacent carbon atom, there is no oxidation on this particular carbon, So, we end up basically with the C-nitroso derivative as shown here. If you look at the reactions of secondary amines when treated with nitrous acid gives N-nitrosoamine as the final product. So, here there is no evolution of nitrogen gas. So, this is the difference between the primary amine and the secondary amine. The primary amine actually gives a corresponding alcohol derivative with the loss of nitrogen gas. The secondary amine gives only the N-nitrosoamine derivative. There is no nitrogen gas that is evolved in this particular reaction. And when we talk about the Lieberman's nitroso reactions, so this particular nitrosoamine, which is generally yellow in color, is warmed with a crystal of phenol and a few drops of concentrated sulfuric acid gives a green color solution. So, when we make this solution alkaline with the help of aqueous sodium hydroxide, the solution turns deep blue. So, these are all the ways by which secondary amine can be tested. The next one is a Halfman exhaustive methylation. So, when an amine is treated with excess of methyl iodide, that leads to quaternary ammonium salt. So, this is a quaternary nitrogen, and since we use methyl iodide, we end up with a iodide salt, and this reaction is called a Halfman exhaustive methylation. That means the nitrogen is completely substituted with methyl group as shown here. So, the next one is a Halfman elimination reaction. So, in this particular case, a quaternary ammonium iodide salt is treated with the silver oxide and water. This leads to the formation of the ammonium hydroxide salt. So, the iodide anion is being replaced by the hydroxide anion, and this on heating produces different alkenes. So, this is what is called Halfman elimination. So, that means some groups are being lost, nothing but this, the nitrogen unit is actually lost as NMe3 here as shown here. So, that is what is called, this is a elimination reaction. During this process we end up with the alkene derivatives. So, this alkene formation is dependent on the substituents which are present in that particular compound. So, here the preferential formation of one of the alkene, that is the Halfman product, happens due to the steric bulk of the leaving group. Here the leaving group is the NMe3 group. This is a very bulky group. Because of the steric nature, the bulky nature of this particular group, the product formed, the olefins that are formed are quite different stereochemically. So, in this particular E2 elimination, the base, basically the hydroxide, abstracts a more easily accessible hydrogen atom, leading to the least stable or the least substituted alkene. So, this is opposite to the Zaitsev rule, where we get more branched alkene is formed in that particular elimination reaction, and in the Halfman elimination reaction, the least substituted alkene is formed as the major product. If we look at the regioselectivity in this particular elimination reaction, the regioselectivity is basically controlled by two factors. The first one is called the acidity of the CH bond beta to this leaving group. We have a leaving group NMe3 group. This is the leaving group. Now, there are different hydrogens present on this particular compound. So, we have two types of hydrogen. One is present as shown here in this purple color, another one is shown in this one as a green color. So, we have two different types of hydrogen present. So, this hydrogen is part of a primary alkyl group. So, this is a primary alkyl group. Here, this is basically the CH2 unit from this methyl unit. So, this is basically primary, that means methyl group, and this is basically the primary one. And depending on where the hydrogen is present, so whether the hydrogen is present on the methyl carbon or in the CH2 carbon, we can see different type of regioselective products. That means elimination leads to different type of products. So, if we look at the elimination, depending on the acidity, we can say primary is easily lost compared to tertiary. So, this stability is very similar to the carbanion stability. So, in this particular case, we have the methyl group here. So, one of the terminal hydrogen is being abstracted by the base. OH minus is the base because this reaction happens in the presence of a base. So, this abstract the terminal hydrogen atom from the methyl group, that leads to this particular alkene, that is the terminal alkene, which is the major product. So, this is the terminal alkene, and this is the major product formed in this particular case, because this CH bond is more acidic compared to all other CH bonds. That is the terminal methyl group CH bond is having more acidity. So, that is the reason the base easily abstract this particular hydrogen atom. And if you look at the steric effect in the transition state, what happens is, for the E2 elimination to occur, we have anti-periplenarity arrangement. So, that means the hydrogen which is lost and the NME3 group which is lost. So, these are all the two groups which are lost during the elimination reaction. They both has to be anti and periplanar. They should be in the same plane and they also should be anti to each other. So, this is an important requirement for the E2 elimination. So, that leads to the formation here as shown here as the major product. So, if you look at this particular hydrogen, that is the CH2 hydrogen, we have two hydrogens. So, depending on which hydrogen is lost, we actually end up with a trans and cis product. The trans and cis alkenes are formed. So, how we get two types of alkenes can be shown from this particular diagram. So, in the Newman projection, when we look at the hydrogen which is present here, that is a CH3 unit, CH2, we have two hydrogens are there, and which hydrogen will be removed is basically governed by the E2 mechanism. So, in this E2 mechanism, the hydroxide will abstract the hydrogen atom which is trans or anti to the leaving group. So, the base will not abstract this particular hydrogen, but instead it will only abstract the hydrogen which is trans to this one. So, in this particular arrangement, the two methyl groups are actually opposite side of each other. So, we end up with the final product which is the trans isomer. And if the molecule rotates little bit, what happens is, now this methyl groups comes to this side and this hydrogen goes to the top, this hydrogen comes here. In this particular case, the methyl groups are on the same side, both the methyl groups are on the same side. Now, the hydroxide can actually abstract this particular hydrogen which is now trans to this leaving group. That leads to the formation of the cis product. So, this is how we can actually explain using this particular E2 anti-periplanar arrangement the different products, that is either the terminal alkene or the internal alkenes, both the cis and trans isomer, how they are formed can be explained. So, next let us look at the Hinsberg test. So, here in this particular case, this reaction is used to test whether it is a primary amine, secondary amine or tertiary amine. So, the reagents used for this reaction is basically benzene sulfonyl chloride and sodium hydroxide. These two are reacted with amines. So, depending on whether we have a primary amine or a secondary amine or a tertiary amine, we end up with a different type of product. By this test, we can actually identify what is the amine we are dealing with. So, if you look at the primary amine basically forms sulfonamide derivatives which are soluble in base. So, this is the first one, and in the case of secondary amine, this also forms sulfonamide, but they are insoluble in both base and acid. So, this is how we can actually differentiate between whether it is a primary amine or a secondary amine. And if you look at the tertiary amine, they do not even form sulfonamide, but the unreacted tertiary amine is soluble in acid because the unreacted amine has a basic unit, that is the amino NH2 unit is there, that is amino unit, it is not NH2 basically. We have the tertiary amine, the nitrogen is there. So, this can react with the acid. So, base and acid react to form salt. So, in this particular case, that particular tertiary amine is actually soluble in a acidic condition, that is in acid. So, that is the reason we can actually differentiate between what is the starting material we are using, whether we are having a primary amine, secondary amine or tertiary amine. If you look at the reaction mechanism, the primary amine reacts with the sulfonyl chloride to give the corresponding salt. The sulfonamide is formed, and this is the sulfonamide what we are talking about. We have the sulfur nitrogen sulfur bond here. So, this is having one acidic hydrogen, and when treated with the sodium hydroxide, we actually end up with a soluble salt. So, that is the reason this particular sulfonamide is soluble in base. And when we use a secondary amine, we simply end up with a sulfonamide, but here we do not have a acidic hydrogen. So, in the previous case we have a acidic hydrogen which is responsible for this one to be soluble in sodium hydroxide. Here in this particular sulfonamide we do not have any acidic hydrogen on the nitrogen. So, this is insoluble in sodium hydroxide. In other words, when we try to dissolve it in sodium hydroxide, this is insoluble, and again this nitrogen is being neutral is also insoluble in acid. So, that means this particular material is not soluble in base as well as not soluble in acid. And when we take about the tertiary amine, since there is no hydrogen present on this one, the loss of HCl will not take place in this particular condensation reaction. In other words, no sulfonamide will be formed, and we only have the unreacted starting material, that is the tertiary amine. Now, if we treat the tertiary amine with a HCl, we get a quaternary ammonium salt which is soluble in the acidic medium. So, that is how we can actually differentiate between primary, secondary and tertiary amines. And if you look at the reaction, the nitrogen has two replaceable hydrogen atoms. So, in this particular case, one of the hydrogen is being replaced by the sulfonyl unit. So, this unit actually replaces one of the hydrogen atom. So, hydrogen is here, chlorine is here, these two are lost as HCl molecule, and we end up with the corresponding sulfonamide derivative. And in the case of secondary amine also, we have one hydrogen which can be substituted. So, this reacts with this sulfonyl chloride to give the corresponding sulfonamide derivative. And how do we actually conduct the Hinsberg test? So, we take the unknown amine, this is taken in a small test tube, and we add some 10 ml of water, and we just check for the solubility. Generally, amines are organic compounds are not easily soluble in water. So, if it is soluble, then we cannot do this test. So, we cannot carry any further. If we have something which is floating or immiscible, then we can actually carry out this test. So, the amine is actually shaken well with the water, and any material which is floating can be easily removed, and whatever the suspension we are having, that is used for the test. So, the amine in water is taken, and we add 10% of sodium hydroxide and shake that solution very well. Afterwards, we add 10 drops of benzene sulfonyl chloride to the test tube, and we can use a cork to close the test tube and shake very well. So, if we get one layer, that means completely soluble layer, then we can say we have a primary amine. So, how do we know this is the primary amine? We can actually add a little bit of HCl, and if something becomes a precipitate or something comes out of the solution, then we can exactly say this is a primary amine. And if we have either secondary or tertiary amine, we will actually see two layers. And what we need to do is we have to take out the top layer, which is generally the organic layer, and of course it is going to be little bit turbid in nature. And once we take out that organic layer, and we can add HCl to that, if that top layer which is turbid becomes clear after adding HCl, then that is basically a tertiary amine. But if the turbidity does not change even after adding HCl, then we have actually the secondary amine. So, this way we can actually identify what is the primary, secondary or tertiary amine is given to us in the test. There is also another test for amines, which is the nitrous acid test, which we have seen earlier also, the diazotization reaction. So, the primary amine reacts with nitrous acid to give a clear solution. So, basically what we end up is we will get a alcohol or alkene is formed as a final product after the reaction is over. So, this is the overall reaction, how the reaction actually proceeds. So, this is the diazonium intermediate which is formed, which loses nitrogen to give the carbocation. So, this carbocation now reacts with the weak nucleophile water to give alcohol, or in some cases if it can undergo elimination, then we end up with the alkene derivative. So, as you know how the carbocation can undergo reactions, so the same reactions are actually happening here. So, with that we can actually find out whether the given compound is a primary amine or not. This will actually give evolution of nitrogen. So, this is one of the crucial steps, that is evolution of nitrogen is an indication for how the reaction actually proceeds, and also tells that we have a primary amine. If we have a secondary amine, so what will happen is we will end up with a N-nitrosamine derivative which is insoluble oil. So, something will come out of the solution, then we can say it is a secondary amine. If we have a tertiary amine, that actually gives a clear solution and there is no nitrogen gas evolution. So, how do we can differentiate primary, secondary or tertiary amine is, if it is a primary amine, it will give nitrogen gas evolution. If it is a secondary amine, we will get a insoluble oil and there is no nitrogen gas evolution. If it is a tertiary amine, we will actually get a clear solution and there is no nitrogen gas evolution. So, by that we can actually differentiate between primary, secondary and tertiary amines. Of course, we have seen so far various reactions of amine, and if you look at some of the important uses of amines, amines are basically used as ligands in coordination complexes. Here the nitrogen can behave in different ways. Say for example, we can have a monodentate amine derivatives. Here it is simply the ammonia derivatives given. So, it can also be a primary amine or even a secondary amine. So, they can actually form monodentate ligands with a metal atom. We can also have bidentate. So, here we have a ethylene diamine type unit is present. We have a NH2, we have a amino unit, and there are a couple of CH2 unit connected. Then at the terminal we have another NH2 unit. So, since we have two nitrogen units, these two nitrogen can actually complex with a metal. So, this is what is called the bidentate compound, and we also have heme complex which is a polydentate. We have multiple nitrogen attached to the central coordination metal. So, these are all the examples of various coordination complexes where nitrogen is involved. That means, in other words, an amino group is involved. And in organic chemistry also, we have various amine which are used as a chiral catalyst. So, semicorine type compounds where we have two nitrogen, the amino units are present here, and this is the imino nitrogen, this is amino nitrogen. And there is also another azo semicorine where we have a central nitrogen atom, and bis oxazolene is also another type of catalyst which is generally used in organic chemistry. So, there is a metal which actually coordinates like this with the nitrogen atom. So, here again there is a metal, and we also have diamine type which we saw. This is basically an example of a bidentate type ligand. So, two nitrogen can be coordinating with the metal atom. So, these are all having stereochemical unit. That means, here we have different bulky aryl substituents. So, these confer conformational stability to the compound, and that leads to different types of metal complexes, and they are used as a catalyst in various chemical transformations. And we also have pi box or the pyridine bisoxazolene unit. That means, the central pyridine unit is connecting two oxazolene units. So, this is two oxazolene are there present. So, that is why it is called a bis unit. and this nitrogen, the central pyridine nitrogen and this nitrogen all can combine together or form a coordinate complex with the central metal atom. So these are all the different types of amines which are used as ligands in synthetic organic chemistry in the enantioselective and the diastereoselective reactions. With that, we conclude this session. Let us recap in the summary what we have studied so far. We have studied about various reactions of amine. We saw various electrophiles that are involved in the reaction. That means how the reaction between an amine and alkyl halide takes place, how a reaction between a primary secondary amine and a carbonyl compound takes place, and how amides can be formed by the reaction between either acid halides or acid anhydrides with amines. And we also studied about how monoacyl and diacyl derivatives can be formed, and what are the reactions of primary amine and secondary amine with nitrous acid. So these are all the reactions we have studied. We have also studied about biologically important reaction, that is Edmond degradation. How a peptide can be sequenced using Edmond degradation. We have seen the terminal amino acid can be converted to the corresponding Heidentoin derivative. So how the Heidentoin derivative can be used for the detection of the corresponding amino acid we have seen. And we have also studied about a very important reaction, which is the isocyanate formation or the carbalamine reaction. We also studied about the mechanism, how the reaction actually proceeds. We then studied about the Manich reaction, what are the intermediate involved in that Manich reaction, that also we have studied. Then we studied about the Halfman mustard oil reaction, that means how carbon disulfide is involved in that particular reaction we have studied. And then we studied elaborately about the stereochemical outcome, regiochemical outcome of Halfman elimination reaction. So Halfman elimination reaction was actually first carried out by the Halfman exhaustive methylation, followed by treatment with the silver oxide and water, leading to the hydroxide derivative, which can eliminate to give different types of alkenes that we have seen depending on the acidity of the hydrogen atoms present next to the amino groups, that is the tertiary alkyl nitrogen. How different types of products are formed we have seen. What is the how Newman projection can be used to study about the E2 elimination pictorially, that we have seen. And we have also studied about the various oxidations of primary, secondary and tertiary amines, and how different substitutions on the adjacent carbon atom of the primary amine leads to different products like aldehydes, ketones or nitrous derivatives we have seen. We have also seen like how Carros acid gives different products. So all these things we have studied under oxidation reaction. Then finally we studied the difference between primary, secondary and tertiary amines using different reagents. So in the Hinsberg test we used benzene sulfonyl chloride, and we have also studied about how nitrous acid can be used to differentiate between primary, secondary and tertiary amines. With that we conclude this session. Thank you.